Good day to everyone. We are from presentation group number 7. My name is Tiong Lian. Together with my group mates Ban Zi'en and Yap Ziling, we will be presenting our group presentation on straight edge and compass. Our presentation will consist mainly of 3 parts. The first part will be on Euclid's construction axiom, where we will be discussing on the background and history on the origins of Euclid's construction axiom. For part 2, we will be focusing on the construction for geometric shapes. First of the geometric shape we will be constructing is a right angle triangle with side lengths 3, 4, and 5. Then we will be looking into the construction for a unit square, a regular pentagon with side length 1, and a regular 5-pointed star with side length 1. We have also inserted the general images of the geometric shapes of our constructions. And for our final part, we will be presenting pictures which express and show regular pentagon pattern in the New World.
I'm Yap Ziling and I will start our presentation with a little background knowledge on the origins of Euclid's construction axioms. In the olden days, Greek mathematicians realized that in order to write formal proofs, we require some sort of starting point, most probably simple, intuitive statements in which everyone agrees are true. These established widely accepted and self-evidently true statements are known as axioms. Notably, an essential part of mathematics is proving complex theories by combining different axioms with applications of the rules of logic. The infamous Greek mathematician Euclid of Alexandria, who is often known as the father of geometry, published the 3 axioms of geometry. For axiom 1, Euclid assumed that it is possible to draw a straight line segment between any 2 points, while for axiom 2, it is assumed that it is possible to extend a straight line segment indefinitely. As for axiom 3, it is possible to draw a circle with given center and radius. Axioms 1 and 2 state that we require a straight edge, which is an instrument for drawing arbitrary long line segments. Euclid and his contemporaries tried to avoid infinity, so they worked with line segments rather than with whole lines, as it is more preferable. This is no real restriction, but it involved the inconvenience of having to extend line segments. Today, we replace axiom 1 and 2 by the single axiom, which is that a line segment can be drawn through any 2 points. The straight edge, unlike a ruler, has no scale mark on it, and hence it is only used for the purpose of drawing lines, but not for measurement. Euclid separates the function of measurement from the function of drawing straight lines by giving measurement functionality only to the compass, which is the instrument assumed in axiom 3. The compass is used to draw the circle through a given point P with a given radius R.
I'm Tiong Lian and I will be showing the construction for a right angle triangle with side length of 3, 4, and 5. So, we start by constructing a line segment with side length 1. Without changing the width of the compass, we will mark along the line continuously for 4 times to form line OB with side length 4. We will then draw a perpendicular bisector by using point A and D. The perpendicular bisector formed will pass through line AB at point O. After that, we adjust the compass to side length 1 again and mark 3 times continuously along the line to get point C, which in turn form line segment OC with side length 3. Then, we connect point C and B to form line segment BC. With this, a right angle triangle is formed. As of now, we have line OC with side length 3 and line OB with side length 4. In order to obtain a right angle triangle with side length 3, 4, and 5, we need to make sure line BC is of side length 5. To verify, we need to adjust the compass to side length 1. Note that line BC can be marked 5 times without changing the width of the compass. This implies that line BC is of side length 5. Hence, we can conclude that the triangle OBC is a right angle triangle with side length 3, 4, and 5. Note that we can also verify by using the Pythagorean theorem. The Pythagorean theorem states that the sum of the squares on the legs of a right angle triangle is equal to the square on the hypotenuse, or in familiar algebraic notation, a squared plus b squared equals c squared. In this case, we have all c squared plus all b squared equals bc squared. Note that OC is of side length 3 and OB is of side length 4. Thus, we have 3 squared plus 4 squared equals to 5 squared. Hence, we obtain BC equals to 5. Now I will show the construction of a unit square. So, we start by constructing line AB with side length 1, which is considered a unit. After line AB with side length 1 is formed, we extend the line and mark 2 points on the line by using compass. Then, from the 2 points, we construct a perpendicular bisector which will pass through line AB at point A. After the perpendicular bisector is formed, we adjust the compass to the length of line AB and mark 1 time on the perpendicular bisector to form point C, and this in turn form line AC. Without changing the width of the compass, we construct 2 intersecting arcs by placing the compass on points B and C. With this, we can obtain point D. By connecting points C and D, point B and D, line CB and line BD is formed. Thus, we have successfully constructed a unit square.
My name is Bangzhen. I will continue to talk about a regular pentagon with side length 1. To begin, we will draw a horizontal straight line and choose a point to be point A. Then, in the first picture, you can see that we have assumed the length to be 1. We use a compass to measure side length 1 and then draw a mark on the horizontal straight line from point A. Then we label it as point B. Next, we draw a perpendicular bisector of line AB. The length of the compass must be greater than half of the length of line AB. Then we draw with a compass at the center point A and B and obtain the intersection point as in the second picture. Now you can draw a straight line that connects the 2 intersection points. Next, we want to draw a perpendicular bisector that passes through point B. Similarly, the length of the compass must be greater than the half. We construct the intersection point as shown in the picture. Draw a straight line that connects the 2 intersection points. Next, we measure radius AB and draw an arc from point B with radius AB and label the intersection point as N, where point N lies on the perpendicular bisector that passes through point B. We also measure radius MN and draw an arc from point M with radius MN. Finally, you will get the image shown. The next step is to use a compass to measure radius AO and construct an arc from point A. Similarly, using the same radius, construct another arc from point B and label the intersection point as point C, which is the upper vertex of a regular pentagon. Then, we measure radius AB to construct an arc from point A and from point B, and label the intersection point as point D and point E respectively. such that point D and E are on the vertex of a regular pentagon. Lastly, we connect the intersection point A, B, C, D, and E to form a regular pentagon with side length 1 as shown in the picture.
Now I will show the construction for a regular 5-pointed star with side length 1. First, we consider a line with length 1 and draw a line segment. On the line segment, we mark a point and label it as A. Then, we measure the length 1 using compass, and from point A, we draw a circle with radius 1. Using the same radius, we draw a circle at center B. And similarly, at the intersection point E, another circle has been drawn using the same radius. Now, we draw a line that connects the two intersection points G and E. Then, another line segment that connects the point H and D also been drawn. Similarly, we also connect the point H and F using a line segment. Then, using the same radius, we draw a circle at center I and label the intersection point with the initial line segment as J. Again, using the same radius, we draw a circle at center J and it follows by another circle at center K. Similarly, a circle at center L is also drawn using the same radius. Then, we draw a line segment that connects the two intersection points M and L. Now, we draw a line segment that connects point P and N and another line that connects point P and O, as shown in the second picture. To complete our construction, we connect the intersection points A, I, K, Q, and R with line segments AK, KR, RI, IQ, and QA. Hence, we have shown the construction for a regular 5-pointed star with side length 1. To make sure that the length for each side of the 5-pointed star is 1, we use the compass to measure the length of each side to check whether it is same with the given length 1.
Now we will have a look about some properties of the regular pentagon. From question 3, we have drawn a regular pentagon with each side being side length 1, as in the picture. So a regular pentagon have 5 congruent sides. Furthermore, the sum of the interior angle in a pentagon equal to 540 degrees. If all the sides are equal and all the angles are also equal measure, then it is a regular pentagon. Otherwise, it is irregular. Each interior angle in a regular pentagon is 108 degrees, and its exterior angle is 72 degrees. A regular pentagon can be divided into 5 similar triangles. Now, let's take a look at some real-world examples of regular pentagons. First, the man-made pentagon structure United States Department of Defense is one of the most visible examples of pentagon in real life. For years, people have looked to the pentagon to create appealing models such as infrastructure model. Second example is a football. Most football consists of 12 regular pentagons in black, and 20 regular hexagonal panel positioned in a truncated icosahedral spherical geometry. Now, let's look at some beautiful creations of regular pentagon in nature. They are Petuna, where its 5 petals embody the pentagon. There also have some fruits that are regular pentagons, such as cross-section through fruit of okra and cross-section through fruit of starfruit. All of the examples above are strong real-life representations of the regular pentagon. Thus, understanding the regular pentagon and how it is can be depicted in real-life scenario is critical. That's all for our group. Thank you for watching our video.